So how this is going to work is I'm basically going to go through this slideshow, outline kind of each step that we're going to take, and then I will switch over to the actual Eagle software and walk through the program with you. Now there is a bit of a delay between me talking and the stream. As far as I can tell, it's about 30 seconds. So if you have any issues that you ask me about and I'm going to respond in the stream, please note that I'm not ignoring you. There's just a good delay between that. You can either, if you have any questions along the way, please either you can post in the YouTube chat, which I'll be monitoring, or there's a Discord server, which you all should have gotten the link to. Please feel free to hop in there. I'm sitting in one of the voice channels, so I think I'll be able to hear you and respond. So if you could all either hop in there or just send questions in the Discord chat, that works too. Hopefully shortly somebody else will be here that'll also be able to help answer questions in Discord. With that, I will go ahead and get started. So welcome to Eagle Training 1. So as you all probably know, Eagle is a software used to design PCBs, printed circuit boards. And what we're going to be starting with today is the schematic for that. So if you're not familiar, in the sort of PCB design process, you start out with making a schematic, which is basically just the set of electrical components that'll go into it. You make the sort of wiring diagram, and then you actually place them on a board and route them. One quick thing that I forgot to mention before we get started is there is a link in the YouTube description for attendance. It's just a tiny URL. It also was sent in the Discord. So if you could please fill that out either now or at the end, that's important just so we know that you're here. All right, with that, let's get started. So the first step, can you guys let me know if you've done this? Has everybody installed Eagle already? I'm not sure exactly what was told to you. I know that I think we asked you to download it. But if you don't have it downloaded yet, then we need to, or if most of you don't, then we'll take some time to do that. Can everybody just give me some feedback in the Discord? And there's going to be some awkward silence here as I wait for the stream to catch up. But please let me know. The instructions are on here. You can just download it from the Autodesk website. You will need a student account in order to use it. Otherwise, you are very limited by some things, although it really should be fine for this project. All right, okay. Thank you, Rohan. Yeah, and then we'll walk through setting everything up. So if anybody doesn't have it, please send a message and I'll try and get you set up, but I am going to go ahead and move on. And I'm glad to know that you guys can hear me. Okay, so within Eagle, I'm going to pull it up right here. So you're going to start by doing File, New, and Project. You can actually just do a schematic, which should be fine for this, but I'm going to do a project, and I'm just going to name it Eagle Learning. And then once we've done that, we'll do File, New, Schematic. It's this red one, SCH. And you should get a screen that looks like this. Just a big white space on the right, and then a bunch of tools that we'll go over shortly. So can somebody send a message just once, I guess, since I have the delay, this might be a little bit difficult, but if you can let me know once you've finished that, please go ahead and send a message in the Discord or YouTube. Oh, perfect, thank you. Sorry, it's a little hard for me to monitor both Discord and YouTube at once, so if I miss your message, I apologize. So it looks like now you should be able to see this screen here. Also, if the asking me to wait isn't helpful, please tell me. I'm trying to make sure you can keep up, but if that's an issue, I can also not do that. I'm very open to any feedback that you can give. So Rohan, after naming the project in this menu here, I went ahead and I did File, New, Schematic. It's this one right here, and I'll leave this up for a second. And once you click that, you should see the window that's behind this sort of eagle menu. Sorry about the delay on this too. It can be kind of difficult to be responsive, but I'll do my best. All right. So let me know if you're having any issues with this and I can move back and catch you up, but for now we're going to go ahead and move on. So once we have the schematic up, there's these things in Eagle called libraries. So a library is basically just a set of the components. So you think like, oh, if I need to put a resistor on my PCB, I need to select the specific resistor that I'm going to use. And there's different factors that go into making that. So on the schematic side, there's a little symbol that we'll see in a little bit. And then later on in the tutorials when we go over the boards, which will be at a different session, you'll see that there's actually a footprint which maps out like the actual size of the component and the holes that it'll go through, the pads that it'll mount on. Okay, so what we're going to do is, and let me move this over so I can see it for now. Is we are going to go to the library manager. So that's up here at the top, and you do Open Library Manager. And you should get a screen that looks like this, and it usually does take a little bit to load. Eagle has a lot of libraries built in, and you can get some more. And then you should be able to select this Available tab. Make sure that this Only Show Local Libraries is not selected, because that only shows ones on your machine, and we need to download some. So then what you're going to do is you're going to search SparkFun. And you should see a whole list of libraries. So now what we're going to do is we're going to select, sorry, I need to check my list to make sure I grab the right one. Okay, so we're actually just going to grab all of these. So you're going to do that, and then, so click the top one, Shift, click the bottom one. So once you've done that, so these are just libraries for different common parts, like different resistors and whatnot that you'll use. Later on, if you say find a circuit or a part that you need a new library for that you can't find online, you can actually make your own, which is the third tutorial. So then, once we've done that, we will click Use. And it'll take a minute to download all your designs. So you can see it doing that at the bottom, and then as it downloads them, they go away. And then in a minute, we'll be able to actually use our own. So next what we're going to do is download our own library. Let me check the YouTube comments real quick. Okay. Again, if you're having any trouble not following along, please let me know, and I'll stop and try and help you out. So the next step is we are going to download a library. So I sent a link earlier in the Discord. I will send it again. It's just this tiny URL link. That is the wrong link. Sorry about that. I'm getting used to managing a stream still. So we will go ahead and open up Google Chrome, new tab, paste the link. And then you should get this. It's just a bunch of, looks like garbage, but it makes sense when we put it in Eagle. So go ahead and download that. And then once that is downloaded, you can go back into Eagle, select your library manager. Then you want to delete SparkFun so it shows stuff. I like checking this, although it doesn't work because it's not in the right folder. So I'm going to go to Browse, and then it should be in Downloads, at least for me, or whatever download folder you've used. So for me, that's just my Downloads folder, and then I'm going to select Soldering Workshop Library, Open, and then then you can check this Only Show Local Libraries. It should be the only one that shows up. I'm going to select that and click Use, and that'll tell Eagle to actually use it. Okay, again, let me check the chat things. Okay, so we're going to go ahead and move on to the next step. So next we're going to actually start adding components to the schematic. So once we actually have these libraries in, we can start adding components. So you'll see it mentions this icon. Eagle also, for every tool that you can see over here on the left that I'm mousing over, there's a version that you can just type it out in here. So for instance, this is the add tool, or add part. So if I type add up here and hit enter, it'll bring up the same thing as if I click this. And to get out of these, you can just click cancel or click escape. I usually just use escape. But anyways, so we're going to go ahead and click add part. So then first we're going to start with this frame part. So this allows you to print the schematic quite nicely. It basically adds a box and makes it so that if you send the file to a printer, it's actually helpful versus if you'll, I don't recommend doing this, but in Eagle you can kind of just zoom out forever and it just goes on as far as you want to make your schematic. So oftentimes for more complex things, you can add multiple like multiple pages of circuits. Anyways. So we are going to do add and then search frame. It should be noted you do have to hit enter for it to actually search. It doesn't just live search. So then the specific one we are going to use for this is the A4L-LOC. It's not a big deal if you get the wrong one. They just look different, which we'll see. But let's see. So it looks like I don't actually have that one, and instead of finding that, I am just going to go ahead and select the A3LOC. You can really, again, just pick any of these. They do different things, but they're, oh, I'm sorry, I do have it, I just couldn't see it. But it's just whichever one you want to use for your design. You'll notice in the right we get a little preview, and each one's just slightly different. So once I get that, it's going to give me this part on the right. So you'll notice that I have to move it by the bottom right. That's where my cursor is. And then I'm just going to center it so that the middle's roughly at the origin. So a couple quick controls things in Eagle. To pan, like this, you want to hold down the center click button, so your scroll wheel. And then to zoom in and out, you just scroll. For me, I think you can invert it, but for me, scrolling in zooms in, scrolling out or down, scrolling towards me zooms out. So I'm going to go ahead and place this here. I'm going to just left click, and then it'll place one. And you'll notice that I can place another immediately. That's really useful if you have to say place like 10 resistors all at once. But for now, I just want the one because this is only going to be one page. So I'm going to go ahead and hit escape, and then it'll open up this window again, so I can go ahead and select my next part. Give me a second to check the YouTube comments. Okay, so did you guys, Delbix, I see your message for the link on YouTube. I don't think I can actually comment because I'm not this channel, and I don't have a channel set up. Angelo said he sent the link to the Discord. Did you actually get that? Can you let me know? Sorry about that, and if not, I can see about finding another way to send it to you. So it looks like the link got cut off, so I apologize for that. I can also... Okay, well let me know and I'll keep an eye on that. For now I'll move on. This should be pretty quick to catch up with and we can help you in a minute. But you do want to join the Discord so that we can help you later. If that link isn't showing up on YouTube, I'll put it on the screen in a minute and you can join that way. Okay, so now we're going to move on to actually adding a part. So what we're going to, oh, sorry. I'm in the team Discord, but I don't see you in any voice chat. Oh, so Delbix, are you saying the ROV Discord? Okay, I'm going to send the link. I'm sorry for everybody else. Please bear with me for this. I am going to grab the invite link and I will send it in the ROV Discord. 1 second. Again, apologies to everybody. It's taking a minute. We are learning. Okay. And thank you to everybody else that just joined. I apologize if we were unclear about which Discord to join, but this is the one that we'll be using for these help sessions because these are available to people not necessarily in different organizations in IEEE. Okay. So please let me know if you need help getting caught up with that. Justin can hopefully help you out in the Discord, but if we need to stop because everybody's falling behind, that's my fault, and we will. So the next step is we're going to add this dip switch. So if you're not familiar with a dip switch, it's basically just a row of switches. When they're in one position, it connects. In this particular instance, it would connect pin 9 to pin 8, and otherwise they're disconnected. So we're going to search for this specific part here, dip 08PTH, and I'm going to go ahead and type that out and add it to our Eagle schematic. So I'm going to delete frame and then dip -08 -PTH. And then for me, it's the only one that comes up. So this is clearly the right one. I'm going to click OK. And for this, I'm just going to go ahead and add it kind of towards the edge of my schematic, but not too far. You want to leave a good bit of room on the left and right sides. So each of these red things that's sticking out, we're actually going to make a connection to, which will tell the actual board how to route it. So you want to leave some room around it, otherwise it can get kind of messy, but you can also move it later, which isn't a big deal. So I'm going to go ahead and once again, left click, that will place it, and then we're good to go. So now that I'm done with it, I'm going to hit escape, and it'll bring me back to this. So there's some information about what a dip switch does in here, some further information. But essentially we're going to, I don't think I mentioned this and I apologize for that, but we're making an adder circuit. So essentially this is how you enable each bit of the adder. So let me check the YouTube comments real quick. Okay, it looks like everybody's good for now. So moving on, we're going to next add resistors. So you'll see this talks about pull-down resistors. If you don't know what that is, you'll learn in class. But we're going to search resistor 0603. So 0603 refers to a specific surface mount package type. It's something like, I think it's a metric dimension. It might be like millimeters or something. I don't remember offhand, to be frank. But essentially, if you've ever looked at a circuit board and you see these little black rectangles, it's probably a resistor. And this specifies the actual size of that. So you'll see things like 1208, 0603. And that doesn't actually affect what you'll see in the schematic here on the right. But when we actually go to do the board layout, it changes the size of the footprint, and it changes sort of how you actually have to route it. So it is quite important to pick the right one. Again, for the purposes of this tutorial, though, since we're not actually going to send out the board to be fabricated, it's not as big of a deal. Anyways, coming back here, I'm going to search resistor 0603. So I might have searched the, yeah, so I need to remove the space, and then it'll come up. So again, just resistor 0603, one word. Another note, if you're having trouble searching things in Eagle, you can add a star, an asterisk, to the end of the phrase, and it'll search more things with that. It doesn't search for exactly that phrase, but it searches to things including that, which can be helpful at times. Anyways, we are going to select this, hit OK, and then again, I'll get this. So I'm going to go ahead and place 8 of these. I do recommend you kind of space them out a little bit. You'll notice that I can put these, if I zoom in a little bit, almost on top of each other. But that just looks kind of ugly and it gets hard to read, so I like to give them a little bit of space. Just like this. So I'm going to go ahead and plop down 8. That's 9. So I guess this is a good time to mention, Eagle has a delete tool. It's this little trash can over here on the left. Again, you can either click that or type delete in the box at the top. And then what's important is you need to get the origin of the part. That's generally a theme in Eagle, is if I want to do anything, I have to actually, I'll zoom in for this, click this little crosshair here. Otherwise, it won't actually know what I'm talking about. So you don't have to click like right on it, like here should be fine. But if I click maybe over here, it's not going to realize that I'm doing this part. So that's just good to know. To get rid of the escape or the delete key, you can just hit escape, and it'll always default you to this group feature, which I'll talk about a little bit later. So I'll give everybody just a few seconds just to get caught up there. Another note, it looks like Justin moved to breakout room 1 in the Discord. So if you have any issues, again, feel free to send them in the chat, or you can hop in that room with him and he'll be able to help you out. All right. So this is what whoever decided to make this decided to lay theirs out as, but it really doesn't matter. It's probably a little bit easier if you have these on the right side of your circuit, but otherwise it's not a big deal. But the next step is going to be adding power and ground connections. So we're essentially telling, with these symbols, this VCC at the top here, or this GND at the bottom here, that I'm mousing over. We're basically telling these PCB that everything that's connected to this is what I'm going to connect to power. Really, it just makes sure that when you go to route the board, that they all get connected to the same trace. If you're not familiar, a trace is the actual layer of copper in a printed circuit board that connects everything. So if we connect all of these on the left to the same trace, or the same VCC here, with what's called a net, which I'll show you in a minute, it's going to make sure that they all get the same connection on the actual PCB once we get there. So switching back to Eagle, we are going to once again click the add key, or add part, and then I'm going to search VCC. And you'll see a few things come up. You can choose this one, or really any of these. I'm going to go ahead and choose this one from the SparkFun library that's just called VCC. Just for no particular reason, it's just the one I like the most. And one thing to note, by convention, what's the name of this switch? 1 second, and I will send that. So by convention, VCC, all your voltage connections always point straight up, and then the ground connections generally point down. So I'm going to go ahead and place that, and then one moment while I respond to a message in the Discord. I'm just going to send the part numbers in the Discord from now on. That seems like it'll be easier. Okay. Sorry about that. So coming back, we are now going to add a ground connection. So it's basically the same thing as VCC, except for instead of input voltage, it's going to be ground. So your 0 voltage point. So I'm just going to search GND. If you don't know, that's the general abbreviation for ground. And again, I'm just going to pick this SparkFun one here. It really doesn't matter which of these you use. You'll notice they're all pretty similar. Yeah. So I'm going to place this kind of to the right of the resistors. And this is something too where kind of knowing how power and whatnot's going to flow in your circuit is helpful. So I know that it's generally going to start here on the left at my 5 volts or whatever input I use and kind of come down through the switch, through the resistors, and then down to ground. So once again, just a left click to add that, escape to get out of it. So this is kind of our basic starting point for the schematic. From here, we are going to go ahead and start connecting things. So I'll give everybody a second just to get caught up. we're going to go ahead and get going again. So moving on, we're going to next use, again, the net tool. So that's this little green bend, and I'll show you where that is in Eagle in a second. It is different than wires, which is somewhat non-intuitive, but you just want to use nets for now. So wires are like what you actually do on the PCB, whereas a net is just saying this is going to be connected to this, but I don't necessarily care how. And then I'll figure it out later in the board, which again, we'll talk about later. So coming over to Eagle, I'm going to click the net tool. Again, you can just type that or use it over here on the left. It's this green elbow. And then it won't actually change anything about my crosshair. So what we're going to start by doing is we're going to click on one end of the component and connect it to the next. So we're going to start by doing the resistors to ground. So we can basically draw lines between them, or you can use what are essentially flags. However, the flags can make things a lot easier, if you might imagine. So once we get more complex circuits, I might have to connect like VCC over here to something over here. And if I have to route around all this, that's not going to be helpful to anybody trying to read it. So what I can do instead is add another one of these VCC symbols and place it over here and make that connection. And basically what these symbols do is they're a little different than parts because it doesn't actually represent something on the final board, but it tells Eagle what to name the net. And essentially what that, all nets that have the same name are connected later, even if they aren't shown connected on here. So to explain that a little bit, I will first just left click on R8, move over to where the ground is going to be, move my mouse down, and then left click on ground, and it'll make that connection. So if I right click on that and I click properties, you'll see that it's named ground because I connected it straight to this ground connection. Now, if I come over on the right and connect anything to another one of these symbols or name it the same way, it will also be connected even if they aren't shown a line attaching them. And we'll spend some more time playing with that a little bit later. For now, we're just going to focus on directly connecting them. So going back to the slideshow, it's going to show us how we actually connect everything. So this is an example. We don't actually want to do this. We'll get to that a little bit later. It does let you actually run nets on top of each other, but you don't necessarily want to do that because all these might not be connected, but it looks like they are. Or they might be connected and you might not be able to tell. So usually when when things are connected, you see this little dot, and that means that this sort of T junction is actually connected, whereas if there's no dot, like over here, it means that they're just nets passing over each other. So you really don't want to do this, and that's where we'll start using the name tool. So first I'm going to show you to finish connecting up the resistors, and then we'll actually name things. Just to give a little bit more context, so this is kind of what I was talking about earlier. So this is basically impossible for anybody to read, A, because it's small, but also because like I can't tell which of these connections is going where. It's just not helpful. So we'll use these name tools in order to connect things without actually drawing a line between them. So we're going to go ahead and replicate this schematic over here on the right. So I'm going to go ahead and draw this. There's actually a tool to use this that I'll talk about a little bit later that'll automatically create a lot of these connections. But for now, we're just going to focus on drawing them, and then we can get to the fancy stuff a little bit later. So I'm going to go ahead and replicate this, and then I'll give you all a minute to catch up. So again, left click where I want it to start, left click where I want it to bend, and then left click where I want it to connect. And also, please let me know in the Discord if I'm going too fast or too slow. It's very hard to judge pace when I can't talk to anybody. Oh, I'm sorry, I also haven't checked YouTube comments in a little bit. Okay, it looks like we're good for now. Okay, so now that I have all these connected like this, what I'm going to do is just make some short connections coming out of the right side of the dip switch. It's just like that, and then I'm going to hit escape and it'll let me out of the net tool and make a new one. Going to repeat that, so just a little bit out, escape, a little bit out, escape, a little bit out, escape. So click, click, escape. I'm going to do the same thing on each of the resistors. This is basically telling Eagle that we actually want a net here, but that connected to that part, but we are going to actually connect them by naming them like we just talked about instead. So what I can then do is I can click this label tool on the left, and there's two options in the top. There's this XREF off and XREF on. What this does is this one gives you a little tag when you do it, like this, whereas the other one will just show you the name on a line, which personally I don't like. I like having it in the little box, but it's really up to you. So I'm just going to add one of these labels to each of the nets. On the dip switch, they do get a little bit close together. You could mitigate this by breaking them out and spreading them out a little bit down at the bottom, but we don't need to worry about that for this tutorial. And then I'm also going to add these to each of the resistors. One thing I should mention, to rotate a part in Eagle, so if I wanted to say take this N $12 and rotate it like that, I just do a right click while it's selected. And each right click will rotate it 90 degrees. All right. So again, I'll just give you a second to catch up and check if there's any questions coming in. Oh, that's my streaming software. Okay, looks like everybody's doing okay. So next we're going to look at actually changing the names of nets. So how we start out with that is you can click the name tool, which I'll walk you through in a minute, or you can go through the properties option, which again I'll walk you through. So basically we're going to go through and name each of the nets coming out of our dip switch and going to the resistor something that makes sense. So then if you name two nets the same thing, it'll come up with this little warning. You just want to hit yes. It's basically verifying that you aren't accidentally connecting two things with a name that you thought wasn't used. And we're going to end up with something like this. Alright, so I'm going to go through on my end and change each of my names to be this B0 through and A0 through 3. So again, in Eagle, how you do this is there is a name tool on the left. I'm kind of mousing around it. So I'm going to click that, then I'm going to click my net. Sometimes you have to double click or click a few times. Again, you want to click right on the crosshair. And this one's just going to be B0. And then let me check to make sure I get the order right. Okay. And then I'm going to work my way on down, B1, and so on. And I did name these wrong. You have to start at A0, not A1, so my apologies if you were following along right there. It's not a big deal, I can just rename them. Let me check the comments real quick. Okay, looks like we're moving along nicely. Okay, so then we'll do the same thing for the resistor side. They did do it in a slightly different order on these slides, so I'm going to go ahead and replicate that, and instead of doing this kind of B0 through 3 to A0 through 3, I'm going to do the opposite. And that's just so that the bits of our adder will make sense a little bit later. So this is going to be A3. And then this is where that warning comes up. So because I already have a net on the left named A3, and this net is currently named N$11, it's saying once I rename it, it's making sure that I do in fact want to connect those, and then that's not just an accident. So since I do, I'm going to go ahead and click yes, and then do the same thing all the way along. And sorry about tabbing back and forth. I'm just making sure that I do this in the right order so it looks nice and neat. Okay. So again, I'll just try and catch up on comments and make sure everyone can get to this point. Again, if you're having any issues, don't hesitate at all to speak up. Well, me and Justin are here to help. Well, also, I believe that we'll be finishing early, so if you missed the first part or something, just follow along as best you can, and we'll try and help you catch up at the end. So now we're actually going to add a value to the resistors. So we told it that this is going to be a resistor, and we gave it how big it's going to be in physical dimensions, but we also need to specify the actual value to it, which is obviously important for later when you're actually either using the schematic to try and debug the design, or when you're actually making the design and you need to pick out, okay, which resistors do I need to buy? So coming back to Eagle, there's again the value tool. It's right next to the name one. It's a little confusing because they look almost the same. But you're going to go ahead and click on that. I'm going to click on my resistor, and it's going to give me this warning. It doesn't really matter as far as Eagle's concerned. A resistor is a resistor, and it cares about the footprint. But for when people actually read it, it is important to have values in there. So we're just going to select 10,000 ohms, which you usually just write 10K. I'm going to hit enter. So you're going to notice now this is looking really ugly because my R2 is on top of my 10K. So this is where the move tool comes in. So I'm going to go ahead and select it. This top on the left, it's this kind of T of arrows. And I'm going to stagger the resistors like they showed over there. Now once the nets are connected, they're connected to the ends, so you'll see Eagle will move them around. Just like that. So I'm just going to move it a little bit over here to the right to give us some more room. Yeah. So another thing, I mentioned this earlier, you can change some of these names and the values through the properties. So if you click this info button, I can also go ahead in here and I can click in value. Maybe. I guess it won't let me. I think it's because of the specific part, but for a lot of things you can do it that way. We'll stick to the value tool for now. So I'm just going to go through each resistor and define it as 10K and kind of stagger them so they look nice. One thing to note, you'll notice that when I move this this resistor here, it only lets me move it in sort of discrete increments. But like, let's say I wanted to put it between here and here for some reason. That's because of your grid. So usually you don't show it in the schematic, but it matters a lot more on the board when your physical dimensions actually matter, whereas an inch here is meaningless in the real world, unless maybe you decide to print it. So you can decide to have it on or off. So if I toggle it to on, you'll see that I can actually see this grid. And then when I go to move it, it'll only let me center it on one of those spots. So I usually just keep it off and use the default one in the schematic. There's no real reason to change it, but it's good to know. You can change your units to millimeters, mil, which is 1,000th of an inch or an inch. You can change this number. Again, I just recommend leaving it like that. There's no real need to change it in a schematic. Anyways, I'm going to go ahead and get caught up with changing these, and then we will go ahead and move on. Okay, so you should have something that looks something like this now, where we have our power coming to the dip switch. The dip switch nuts are broken out and then connected to each of these resistors, which each have a value of 10K. So our next step is we're going to add a few different components. So I will go through these one by one. Don't worry, you don't need to write them all down. I will also throw these in the Discord for the ones that are harder to find, like this part. So when you see something like this, that's usually just an integrated circuit. If you're not familiar with that, it's just the little black chips that usually contain silicon, amongst usually some integrated resistors and different other parts. In this case, this is just a set of transistors that make a 4-bit adder. So I'm just going to copy that out of here. I will put it in the Discord for you. And then I am going to go ahead back to Eagle. I'm going to add that part. So it should be the only one that comes up. So I'm going to zoom out a little bit, and I'm going to try and follow the PowerPoint because it makes a nice schematic layout. So I'm going to put it a little ways to the right of what I have currently going on, and then I'll go ahead and add some of the other components. So I'll just put it right over here. And don't worry too much about the layout. That's just kind of to make it look nice. If you're doing like a real design for a real project, you do want to make it look nice so other people can follow it. But otherwise, it's not particularly important. Okay, so next we are going to add 9 51 ohm resistors and 1 additional 10K resistor. So one trick that you can do here is instead, so if I need another 10K resistor, well, I have one right here. So Eagle does let you, if I am in the, if I go ahead and right, okay, let me try and get that to work. So if I right click on it, if you hit escape to make sure you're not currently in any tool, and then you right click on it, you'll get an option to copy. And when I click that, it just gives me another resistor. So, and then when I go ahead and plop it down somewhere, you'll see, okay, now it's a 10K resistor. That's convenient. So then since I need to add 9 51 ohm resistors, what I'm going to do is I'm going to copy this again. I'm going to put it down here, and then I'm going to go in and edit the value. So since this, just enter 51 since it's 51, and now if I escape again and I do copy, I can go ahead and place down a bunch of these. That's just usually faster than redoing each part, but if you prefer, you can add them and then edit them all. Let's see, 5. 6, 7, 8, 9. So hopefully I counted that right. So let's see, what else do we need? So there's a AAA battery part. So let's see what we can find if we search in Eagle for a battery. AAA battery. Okay, so this particular SparkFun library comes up. So sometimes you'll click on this drop down and you'll actually have to pick one of these items. And you'll notice that all of these have the same symbol on the left when I click through them, but over here, but on the right they change. So on the right, what you see are the actual footprints of the part, and that will vary depending on what it actually does. So you'll see this is a 9-volt battery, so it's a specific type of footprint for the actual PCB for a 9-volt battery. So for these purposes, since we want a AAA battery, I'm going to go ahead and pick this one, and I will go ahead and add it. And again, right-click to rotate. I'm just going to put this off on its own. And let's move on to our next part. So now we're going to add 5 of these MOSFETs. Again, I will put this in the Discord, and we'll just search it in a second. Again, only one option comes up, and let me consult. Okay, so we do need 5 of these, and I'm going to consult their layout again because I want this to look nice. So they put them over here to the right, so I'm going to go ahead and do the same. Again, it's just always good to leave some nice spacing between your parts. I'm going to stagger these a little bit, just so I don't get that overlap. Also, I'll talk about move group here, because it seems like it'll come in handy now. So I've run a little bit too far off to the right now, you can see. And I can see, okay, well I have some extra space on the left. This really shouldn't take more than 1 page. How do I move this big group of things all at once? So if you come up here to the group tool, you can do this, and then make sure that you really get everything. It kind of highlights, it's a little hard to tell. And I'm gonna right click on just one of the components at the origin. The resistor is usually the easiest. And then click move. So usually that just selects the one, so I'll hit escape. But then if I right click again, it'll give me the option to move the group. And then you can see it lets me move everything at once. This tool can be a little bit finicky, so if it doesn't work, that's not a big deal. But it is nice, especially when you want to move a big group of things around. So I'm going to move that over there. And then I'm going to move this part over here. You'll notice to move this, I had to click on this red crosshair. They're not always at the center of the part, and that's where you actually have to click in order to move things. So if I click up here, I guess you can't tell that I'm clicking, but I am. It doesn't do anything. But if I click up here, it will in fact move. I apologize if the bell is coming through the stream. I thought I had it muted. I don't actually know how to mute that though. There's a message in the Discord if anybody's not on there. So I apologize. I'm sure there is a way, but I would just try to... there's probably a setting somewhere. I will let you know if I ever figure that out. Anyways, so now I want to move all these parts back into the actual diagram. So again, I'm going to select them all. Then click away, I'm sorry, select all, right click one, move, escape, move group. There might be a shorter way to do that, but that's the one that I've figured out, and I'm just going to put them kind of over here for now. They might move as the design progresses, but again, it's not a huge deal. So the last thing that we need then is this LED 5mm. So again, I'll send that in the Discord. And we're going to add 13 of these, so 8 to the right of the dip switch, and then 5 to the right of the adder. So again, add part. So again, we're going to open this up. So if you just try to select this, it won't have an actual footprint. You do need to pick this one so that when we go to make the board, it works. All right, so again, I want 8 over here. So, and once again, it's right click to rotate a part. So I'm going to go ahead and add 8 of these just right below here. 1, 2, my spacing got messed up. Another thing to note, if you click this little down arrow on the very right side of add, it lets you pull up the recent items, which can be kind of nice. Okay, I apologize. I spaced those out too much, so I'm going to do it again. I'm probably being too much of a perfectionist, but anyways. And then I'm going to move this down a little bit for later. Okay, so that should be each of the parts. Just to reiterate, it's this part for the adder, 9 51 ohm resistors, 1 10K, 1 AAA battery, 13 of these, so I'll add the other 5 in a moment, 5 of these MOSFETs, and then, we still need to do the capacitor. So let me go ahead and add the other 5 of these, and then we'll add our capacitor. These I'll just put over here. I have a lot of room. Okay, and then the capacitor, it says to just pick any 0603 package size capacitor. So what I'm going to do is search capacitor star, see what that brings up. So we see this first, just capacitor library that I have. And then it gives me a description. So I want to find one that, so these are all through-hole packages, so this isn't what I want. And for reference, so when you see this green pad, that means it's a through-hole part. That means that there's leads that stick out of it that physically go through the board to get soldered. But when you see, and give me a second to find it. So for example, these red parts mean that it's a surface mount part, which means that there's a pad on top of the PCB that it gets soldered to, but it doesn't actually go through. So these are used in a lot of modern electronics just to make things smaller because it takes up less space and only one layer. And then on the right here, you'll see that this says 0402. So that's a certain package size. You'll see again, it lists it here under footprint. So we want to pick an 0603 option. If we look at each of these, they're pretty much the same. So I'm just going to pick this one and run along with it. And then I'll just put that up there. Okay, so now you should be able to have all of these parts added. So we're going to go ahead and start wiring things up. But first, you should have something that resembles this, just that set of resistors. It looks like they didn't add all the LEDs, but anyways, we'll get to that. So this talks about that move thing that I mentioned, so you can use move group, and then, okay, so the other way to do it is you can click and drag, click away, and then click on one of them. It is kind of weird, so again, I'll just run through that real quick. So how I like to do it, let's say I wanted to move these transistors again, I go to the group tool, highlight all of them, then I'm going to right click on one, select the option that I want, it'll select just that, then I'll hit escape, it'll send it back, then I'll right click anywhere that's not on one of the parts and do move group. And apparently I messed it up. So highlight them all, right click, move, moves one, hit escape, right click again, move group, and it should select all of them. I don't know why it's so convoluted to do that, but that's what the Eagle developers decided to do. Alright, so we're going to start our next round of connections. So we're actually going to connect the dip switch up to that now, like so. So you'll notice, let me go to actual presentation for this because it's kind of hard to see. So in this diagram, what they did was they connected each of these straight to the net. So that label is still there, so this is still making that connection earlier that we did to the resistor, but it's also being connected to here. So on your actual PCB, that might make kind of a T shape. So you can do it that way, and how you do it is you just come over the net tool, and you'd do something like that. You'd want to route it a little bit better. Also, if you want to rotate how it's routed, like the angle that it does, you can right click and it'll try the other way. So I'm just going to go ahead and add labels like we did for the resistors, because I think that's a little bit easier, but you can do either approach. So again, to do that, we're just going to add a little net on each end. And then we do want to, I'm going to go ahead and copy this ground symbol so I can put it down here. And then we can connect each of those to the ground. Like that, and then each of these can just connect to this net, and they'll all be connected now. So it is important you make sure that you get that little dot there. Oh, I'm going to Discord for a moment. I'll be right back. So Justin made a good point. If we want to add nets to everything in an IC, what you can do is you can right click on it. Sorry, I have to hop back and forth between audio sources. Go ahead, Justin. It's a little bit laggy. So I'm going to right click here and then go to breakout pins. And then I can select one of these options. So I'm just going to do default because that'll just give it its own net names. And you'll notice that when I do that, sorry, I'm listening to Justin in Discord, but you'll notice when you do that, you get all these flags nicely made for you that we can then rename. So I'm not quite sure what it did for that one. It is possible that, no, this shouldn't be connected, so I don't know what that did. I'm going to try that one more time and move this capacitor. Maybe that messed it up. So you're going to right click on here, breakout pins, default. Yeah, so I don't know what it did earlier, but then we'll get all of these so we don't have to do that by hand. So I'm going to go ahead and wrap up my LEDs, but that's just good to know, and you could do something similar for the dip switch. Just wanted to make sure my audio is still good. Okay, so again, I'm just going to add labeled each of these. And then I am going to go to the name tool, and I'm just going to connect it to each one of these. So again, it's going to be B0, and then it'll ask me, and then I'm going to do B0 through B3, and then A0 through A3. Okay, so now those LEDs should be connected, and we can go ahead and move on to the next step. So the next step talks about connecting some of these parts to the actual adder. So I'm just going to go ahead and read through this. So the 51 ohm resistors that we added act to limit current going into the actual adder circuit, so that when there are different current spikes after we toggle different switches, it doesn't blow up the circuit. So essentially each of those will again get connected to our A0, A1, B0, and all that. And then we'll also add in a carry-in signal that we're just going to tie to ground. And then, so we're not actually going to be worrying about that. Yeah, I apologize. And then this also outlines a little bit of just some of the good circuit they design, like we add a 10K resistor on the carry-in to limit a current spike. So I'm going to go ahead and replicate this on my diagram, and you guys can follow along. So since I have my resistors, sorry, there's a quick question in Discord that I'll answer. Can you put a label direction on the part without first adding a net? So no, you can't, unless you do that thing that I showed on the IC where you right click, breakout pins, all pins, and default. So the issue is that Eagle doesn't actually make a connection to like this end until you add a net. So, and then nets are how it actually references between parts, so that you essentially have to add the little stub first. Anyways, I'm going to go ahead and connect up each of these to each of these. So I'm going to try and name these, well, so the left sides of these will each go to this A0 through B0 essentially, or A3 through B0. And then the right side will think of something to name it. So again, it's the same process. And this actually, I am going to move this piece down here because I think that it'll be clearer for my diagram if I do it that way, but you can do it any way that you want. So in order to do that, I'm going to delete all the nets. So I'm just going around with the delete tool and removing all the nets. Then I will grab my move tool. I will come down here. These conveniently line up. So then I'm going to go ahead and just connect these straight up. So one thing I did just here is I clicked in the wrong spot and did this to this, and you can just do this to this, but you'll notice you get this dot here. So generally you just want your net to go straight from one place to another. You don't want it to sort of do any random sidetracks. Like I could do that, and then when I go to make the board it would be fine, but it just keeps it cleaner, and sometimes these can cause issues that you just can't really catch later down the line. So I'm just going to go ahead and undo that and just restart and do it like that. Okay, and then we're going to bring nets out this side so that we can connect to what's above. So I'm just going to add a label on the left side here that matches up what the actual part that they've made for us says. Personally, I find it easier just to add all the labels and then adjust them, but that's just personal preference. You could add each one at a time and then rename it, or you could even rename it then add the labels. It's totally up to you. And then you'll notice this carry-in pin in the design is just connected to carry-in, which I don't believe that we've connected yet. So then we're going to grab this 10K resistor and bring it down here, just like they have. I'm going to rotate it so I can just go right here. I'm going to go ahead and copy my ground symbol. Got to click on the origin, copy, get a new one, pan over here. Add the ground right at the bottom. And then what I'm going to do is make this connection like so, and also connect our IC to ground. So I can just click in the middle of the net and make that connection. It adds the dot, but this time I actually want it because I intend for it to go there, and then connect the bottom of this to ground, as well as make this connection here. So usually you want to try and avoid making these dots right where a pin comes in. So a better way to do this might be if I undo a couple and I move this resistor up one, I can do it like this and then make this connection. And that's just generally good practice, because that way you know that there's not something that you didn't realize here. You can just clearly see that it's these two nets connecting. Okay, so now we're going to go ahead and connect this to power. So you can see we use the same VCC label, but there's also a bypass capacitor. So bypass capacitors are added for a lot of reasons. You'll learn about them through your courses if you haven't already. They perform a number of things, but one thing, if you've taken like early ECE 201, you'll notice that, or you'll know that a capacitor will resist a change to voltage. So if you have any sort of, let's say your regulation circuit has a little bit of noise on it and it's switching, this capacitor can help smooth that because it resists that voltage change, so you'll get a little bit less noisy input. So a lot of designs will have something like that, you'll notice, and it's usually just specified on the specific data sheet for that design. Just something good to know. Alright, so I'm going to grab my capacitor, bring it down here, and then I'm going to copy my VCC signal because I want to use the same one. I'm going to put it up here, and then VCC will go straight into here. And then I'm going to make a little tee off, go to my capacitor, copy my ground symbol. Again, I'm missing the origin, that's why it's giving me these issues. So it helps to zoom in and just click right on that plus. So right now this is going to be in a bad spot because you can't see it, so I'm going to actually undo that and move all of this up a little bit. So again, just the usual difficulties with move. Move it up, then come down, copy my ground symbol, and then go ahead and make that connection. So again, if you think about this, if there's 3.3 volts up here, it's just going to make it a little bit less noisy on the input, and also just, well, there are other helpful effects that you'll learn about later that I won't get into here. So once this is done, we can go ahead and move on to this step. So this is where we connect each of the transistors to the LEDs. So here I'll actually explain a little bit about how this works. So basically what we've been building is a 4-bit, or 8, I guess, well, 4-bit output binary adder. It's 4-bit, I'm sorry. So basically each of these inputs for each bit, A1, A0 and B0 would be the least significant bit. If A0 and B0 are both 0, this will output a 0. If 1 is a 1, this will output 1. If they're both 1, it'll add 1 to A1 and B1, and so on. It's just basic binary math, and if that doesn't make sense, we can talk about it some other time. It's not really relevant here. Then these outputs on the right come over to a transistor. When this signal goes high, the transistor will then make that connection inside and allow current to flow through the LED into ground. When the signal is low, the transistor is open and that current can't flow, so the LED won't light up. So I'm going to go ahead and move some of these parts around just so things look nicer. Again, I could do more of this with nets or with these labels, but usually you don't want to, like, if something's part of a subsystem, it's kind of nice to connect it for things that might not be intuitive, but if it gets too messy to read, you can always use the labels. It's just a kind of personal preference thing. So one thing I'll notice here is this isn't letting me line it up how I want to. So this is where changing your grid size can come in handy. So I want these to line straight up. So what I'm going to do is hit escape, and then I'm going to change my grid size down to 0.05. And now hopefully it'll let me line them up. And you'll see I can line them nice and up how I want them to. And I'm just going to try and do this to make it look neat. Feel free to use whatever approach you would like for laying this out. This is also where turning, like if I want these to have the exact same spacing, this is where turning the grid on can come in handy. It's a little bit hard to tell, so I might want something bigger, but say I can move this over a little bit. I just like my schematics to be nice and neat, so I usually spend some time doing stuff like this, but again, that's largely down to personal preference. So here's another thing, I'm kind of running out of room down here, so I'm going to go ahead and just move everything up a little bit. Okay, so in chat somebody said my Eagle program crashed. Is there a temp directory where my schematic is saved? Unfortunately, probably not. If you didn't already save it. So this is a good time to go ahead and save your schematic and just name it whatever you want. So I'm going to name mine Eagle Learning. Caps lock on. So this is a couple things. Save often. If this happens to you for this, don't worry about it. For the purposes of the other workshops where we use this part, or the schematic, we can just send you one to use. If you just want to continue along and do the parts that we haven't done yet, that's fine, but we've shown you sort of most of the skills that you're going to learn from today already, so don't worry about it too much otherwise. So I'm going to select all these parts and do the move group, again, just to make things a little bit neater. But you'll notice I grabbed some of those names too, so that's not what I want to do. So I'll probably have to move these in two groups, but that's all right. So I'm just going to bring this up, line it back up. And you'll see I just line these all up nicely so we can replicate that. So one other question in the chat, okay, are the slides being uploaded later? I think I can send you this Google Drive. If not, I'll figure out a way to get them to you and I'll post it in the Discord. Regardless, we'll make sure that there's some way that you can get them and follow along. And again, if you've learned the stuff, you don't need to like remake it. We will make this available. But if you do feel like you want to do the practice, that's definitely a good thing to do. So again, I'm just going to go ahead and make some of these connections. And if I'm going faster than you are, don't worry, we're approaching the end of this, so we'll be able to hop into Discord and just help you out with whatever you need. Justin is still there, so if you have any questions, please feel free to hop in the room with him and ask. He'd be more than happy to help you. Let me check the YouTube chat too. Okay, yeah, nobody's been using that, but I want to make sure. Alrighty. So if you didn't see in the chat, Justin just sent a pre-made schematic that can be helpful. So if you have had any issues or you want to use that for the next part of the training, feel free to use it. So I'm going to change my grid back to that larger size. I just think it's easier to line things up that way, but now that all this is set up, actually I take that back, I apologize, because now I'm going to have to route things on those boundaries. So Eagle only lets you really do stuff on this grid, so since I now have some things that wouldn't be aligned if I used the larger size, I'm going to keep it at this smaller grid. Alrighty. So now we're just going to add these individual ground connections and connect all these to power. So once again, I'm just going to copy this VCC signal, put it up here, and then do that. Actually, it would be better, so I'm going to do this, come over here. If I didn't say it before, if you want to, so I come here and I want to do a bend and eagle, just click, that locks everything you've made so far in place, and then you can come down like that. And then each of these will just go up. And then we'll add a ground for each of these. So again, I'm just going to copy this ground connection. Give a little bit of space. It doesn't let me keep pasting, which is a little bit annoying, but not a big deal. So I'm just moving these so the spacing's nice. Like I said, I like to make them neat, which is difficult at times. Then I'm going to make each of those connections. Let me check Discord. So the question is, do you know why sometimes when I move something, it doesn't align with the grid anymore? So when you move a part, it's essentially centered on this little origin here, and I'll blow this way up so it's a little bit obvious. So you'll see this little crosshair here, and that's where you actually have to move the part. So if I change my grid back to 0.1, you'll notice that that isn't actually aligned, or the offset between some of the inputs isn't always the same. Like, it isn't always your grid size. Sometimes it's larger or smaller for some symbols. So when those are offset, it can mess up the grid, essentially. I hope that makes sense, but basically everything that you do in Eagle has to line up with the grid, but sometimes relative to the origin, but sometimes the other parts don't. And like, if you have a net that's a little bit off, it'll figure it out. So like, if I were to add, if this were to not be aligned with the grid, it'll snap it to it for me, but it can be difficult to deal with sometimes, so it's usually just best to change the grid size as you need. Hopefully that answers your question. Justin sent something in the chat that hopefully helps as well. All right, so we're in the home stretch. So they essentially talk about, okay, so now we're going to connect the battery. And then we're going to connect each side to the respective plus and minus, essentially. And then we're going to add some connectors. So I'll start with the battery, and then we'll add the connectors. So if I come back over to my battery, and I'm going to check which side is which, because I don't remember. If we look in their example, so the long side goes to VCC and the short side goes to ground, and I'll show you that. So mine is currently upside down, which I don't like. I want VCC to go up, so I'm going to flip it around, and I'm just going to kind of move it down here so it's out of the way. So once again, we're going to grab those supply symbols. So I'm going to go ahead and copy this. One thing to note too, I can't remember if I mentioned this. If I did, I apologize. If you use this VCC symbol, everything that's connected to the same power has to use the same VCC symbol. If you choose like 3 different VCC symbols in your design, that can lead to problems, because sometimes you can do it intentionally. Let's say you have a 3 volt and a 5 volt line. That's what you want to do. But if you have the same voltage and different VCC symbols, it's not going to figure out how to connect them. And that's where, personally, I prefer to just name like one of my nets, like VCC 5 volts, instead of using the symbols. But that can be a little bit harder for other people to follow. Either approach is valid. So I'm going to go ahead and make that connection, and then we'll add our connectors. Excuse me. So the connectors that we're adding are CON 03 and CON 04. I'll send that in Discord. Or CON 1. And then we're going to go ahead and search that up in Eagle, just like we have been. See, there's only one part that shows up, so I'm just gonna throw that out right there where we have some room. And then I'll go ahead and add connector 1 and add that as well. So then we're gonna come back, and then we're essentially providing our carry in and carry out as other connections, just for whatever we decide we want to do with the circuit. In the middle is the ground. And then, again, I'm going to have to present, I believe, yeah, so the input is 3.3 volts. All right, so this is where we can use that trick that Justin mentioned earlier. So if I right-click on this, I go to Breakout Pins, All Pins, Default, and then we'll get these 3 little breakouts. So then, again, this one I'm going to name Carry-In, or C in. That'll connect it to that one we made earlier. This one I'm going to name C out. You'll notice that isn't going to connect to anything. It's because we haven't named this net. So because of that, I'm going to go ahead and name this net C out right here. So first I'm just going to add a little label to it, and then I will right click and do name and call it C out. And then that'll connect those for us. So then this connection, despite being wired straight to this transistor, is also going to here. Then this middle one, I'm actually going to delete that because we're going to connect it to ground, and I could do it by naming it, but we've been using the symbol. Okay, so again, I'm just going to copy this ground symbol. Then we're going to do out, down, and then lastly, we're going to just do another net and then add a label that's 3.3 volts in case we decide we want to input that. All right. So Okay, so I'm going to take a minute. If everybody's caught up with that, we do have some bonus material that we can go through that can set some different, well, I'll get into that in a minute. So I'm going to take a minute, drink some water, and then give everybody a chance to catch up. Again, questions, hop on Discord, throw them in the chat, and then we'll go over some of this bonus material. And one quick reminder, if you haven't already, please go ahead and fill out the tiny URL link for attendance. That just helps us out. And especially if you're here for a specific organization, it's good to know that you actually came. So I'm going to cover this last bit real quick. If you haven't gotten here yet, you don't have to do this. And then we can go ahead and help you out. Yeah. So essentially there's these things called net classes that let us group different nets into different areas. What that means is, I said that poorly, but essentially we can say, okay, so this net is going to be for power. So then when I actually go to route my board, it always has to be so wide, which is important because it means that when I'm actually routing the board, a lot of times you do have that constraint that your power traces actually have to be wider than a signal because it has to carry more current and you don't want it to burn up. So we're going to go to edit and net classes, and then we're going to add a few classes. So in here, edit, net classes, and then we're going to add power and signal. And then we're going to add 3.3 volts as a power class, just like so. And then we're going to add all our signals to the signal class. So all of our signals are the output ones that we care about. So that's B0 through A3. Again, I'm just shift clicking to do that, and then carry in and carry out. So you have to click it and then select, which I forgot. Move them over to here. So then once that's all done, this is kind of what I was talking about where you can set minimum width requirements. So then once we have gone through and added each of the nets, I'm going to click rules. And then for each of these, I can set different rules. So width is the one, again, that I talked about. So you want to have a certain minimum width for your different traces on your actual PCB. And power oftentimes has to be wider. But you can also say, well, a lot of times PCBs have mounting holes where you actually put a drill through it and you can bolt it onto something. So for that, you can say it needs to have a certain clearance from that. And then in general, you can have a clearance from other traces. So say you have a signal line, but it's also going to be close to your power line. Well, that can inject noise and cause problems. So you can set, if I have like a high fidelity signal, you can set a higher clearance for it. So in our case, we're going to leave the default at default and then copy these values. So for power, we set a 30 mil width minimum, and for signal, we set an 8 mil width minimum. And again, if you're not familiar, excuse me, mil is 1/1000th of an inch. It's a unit that PCB designers use and no one else. Then just go ahead and click OK. And then that should be it for the material. Good job. In a week, same time, same virtual place. We have our next session, which is where we take the schematic or the one that we provided and we actually put it on a PCB, which is where it gets really exciting. So make sure to be there, and again, Justin and I will be available over Discord to help for the next little bit. If you have any questions or anything, please let us know. Also, if you have any like general feedback for how I did here, I would appreciate it. I've never really done a stream like this before. Whether it's just I went too fast, too slow, or audio quality, or any of that, please let me know. I'd appreciate it a lot. Otherwise, thanks for coming. I'll leave the stream up for a little bit in case there are questions that I'll address to everyone. Alright, well, it doesn't look like anybody has any questions, so I'm going to go ahead and cut off the stream. If you have anything that comes up later, please just go ahead and send a message to me or Justin, either in the IEEE Slack, or you can send something here in the Discord. And I look forward to seeing you guys next week. Thanks for coming, and I hope this was helpful.